All right, so this video has us reviewing solving linear systems by substitution and elimination. Again, both of these topics were covered in Algebra 1, so we're just really going to hit and review them hard to make sure you are comfortable with them. Now, we already did graphing, so these are our second two methods, again, with this. All right, so let's start with some substitution. What's really nice about substitution is it, again, is just using basic algebra and solving stuff. So what we look for in a substitution problem is that one of the equations is either solved for y equals, or it can be solved for x equals. As long as one of those equations is solved like that, or can be solved pretty quickly using that, we might want to try the substitution method. So I'm going to take that equation of 2x minus 1, and since it's solved for y, I'm going to substitute it in 2y in my second equation. So instead, I'm now going to have my second equation read 3x plus 2. I'm going to substitute that y value with 2x minus 1 in there is equal to 26. And now it turns into just a basic Algebra 1 solving equation. So I'm going to go ahead and distribute. So now I'm at 3x plus 4x minus 2, all equals 26. I'm going to combine my x's, giving me 7x. I'm going to add the 2 over to the other side, giving me 28. Divide both sides by 7, and I get 4. Okay, now what we need to remember is we are only half done at this point because we know that our answer needs to be written as a coordinate point, and we have found the x value, but we haven't found the y value. So we need to take this 4 and plug it back in. I typically like to plug it into that first equation because it's going to pump out the y value really quick. So I would have y equals 2 times 4 minus 1, so 8 minus 1, so we get out y value of 7. So I will be looking for your answers to be written as a coordinate point like that. If we try a second example of substitution, again, our goal is always for one of the equations to be x equals or y equals when we're solving. This way we can substitute it in. Now, looking at this example, this second equation is pretty close. The only problem is this negative. Okay, so I'm going to divide both sides by negative 1. And now this equation would read y equals negative 2x plus 2 instead. Okay, since I have an equation that reads y equals now, I can take this and I can substitute it in where I see y in the other equation. So rewriting this, I would have 5x plus 6, and then instead of the y, again, we're substituting in negative 2x plus 2, and it equals negative 9. All right, I'm going to use my distributive property. So now I'm at 5x minus 12x plus 12 equals negative 9. All right, this would give me negative 7x. All right, I'm going to minus the 12 over, which gives me negative 21. Divide both sides by negative 7, and I get positive 3. Okay, so again, final answer has to be written as a coordinate point. I know the x value. I do not know the y value. Now, the only thing with something like this is we don't want to plug it into the one that we rewrote. So this guy right here. We always like to plug it into an original. So I'm going to plug it in going, let me change color so it makes sense. We got 2 times 3 minus 2 is supposed to give me negative y. So that would be 6 minus 2 gives me 4. 4 equals negative y. Divide both sides by negative 1. It looks like y is negative 4 this time. Okay. Now, I do want to talk about checking your answers. Okay, if this was my test or my quiz, regardless of the fact that you get to use your notes and everything, I would take that coordinate point and I would plug it into this other one and also make sure it checks. If it doesn't check, then we know that we did something wrong. We probably want to redo something because this point that you just solved for should work in both equations. Okay, so I would definitely be practicing that once or twice on my homework, and then I would also be making sure I do that on my tests and my quizzes. All right, elimination. All right, with elimination, what we want to talk about on here is we want to make sure that all of our x's are stacked up on top of each other and all of our y's are stacked up on top of each other. Now, having said that, one of the nice things about doing elimination is on here we get to actually solve for a letter by getting rid of another one, hence the word elimination. Okay, so we want to actually make the coefficients match on here. Okay, and I like to keep my numbers small, so I think I'm going to aim to make these guys the same. So in order to do that, 3 and 5 share a multiple of 15, okay, which means I'm going to take that first whole equation and I'm going to multiply it by 5, and I'm going to take that whole second equation and I'm going to multiply it by 3. So if I do that, my new first equation would be 25x minus 15y is equal to, and we may need our calculator for this one, 42 times 5 gives us 210. All right, multiplying the second one all by 3, we would get 24x plus 15y is equal to 84. Okay? All right. Make sure I did all my math right, just double checking myself. All right. So if I want to get rid of those y's, okay, I'm going to add these two equations together, because if I add those two equations together, then I'm going to go ahead and get, what is that, 49x is equal to, when I look at what happens to my y's, they get eliminated because negative 15 plus positive 15 gives me 0. So again, like we wanted eliminated. And 210 plus 84 gives me 294. Okay, divide both sides by 49. All right, and it looks like I'm getting an x value of 6. Okay, now that we have our x value, we can take this guy and we can plug it into either one of these equations to figure out what y is. I'm going to do the first one. So 5 times 6 minus 3y equals 42. So I have 30 minus 3y equals 42. Minus the 30 over, careful with your signs. And divide both sides by negative 3. We get y equals negative 4. Now, just like on our other examples, please make sure your final answer is written as a coordinate point. So 6, negative 4. All right, let's do one more elimination. Ooh, I like this one because the y's are already equal to each other if we look at these coefficients right here. So I'm going to put a big plus sign. All right, 4x plus negative 12x gives me negative 8x. And negative 25 plus 19 gives me 6. Divide both sides by negative 8 will give me 0.75. Or you could write it as 3/4. Okay? All right, we got to figure out what y is. I'm going to plug this in. So I'd have 4. I'm plugging it into this first equation right here, guys. It doesn't matter which equation you plug it into. All right, so 4 times 3/4 plus 7y equals negative 25. So 4 times 3/4 is 3. Okay, I'm going to minus the 3 over. That would give me 7y equals negative 28. Divide both sides by 7. Looks like I get a negative 4 out. Remembering to write our answer as a coordinate point, we got 3/4 and negative 4. All right, last problem of the day. We are doing the story problem from page 193 out of the textbook. All right, so it says a coffee blend contains Sumatra beans that cost $5 a pound and Kona beans, which cost $13 a pound, and the blend costs $10 a pound. So let's talk about our money on here. So the first thing they bring up is Sumatra beans. So I'm going to put that as my x variable. Second thing they bring up is my Kona beans. Okay, so I'm going to put that in there. So let's see, Sumatra beans are $5 a pound, plus my Kona beans, are 13, let me fix that on there, are $13 a pound, and the whole blend costs $10 for 1 pound. So we're just talking about a pound of coffee, okay? Now, we do need to, if the blend, it says how much of each coffee is in a 50 pound. So let's worry about the 50 part later. We've been talking about 1 pound. Let's keep it with 1 pound. So there's some Sumatra beans in there, plus there are some Kona beans in each 1 pound bag. Okay, let's solve that first, and then from there we'll worry about that 50 pounds. Okay, now it's set up for us to do elimination right now, because we've got the x's on top, the y's on top, and then our number separate. So I'm going to take that second expression, and I'm going to go ahead and multiply that by 5. So my first one remains the same at 5x plus 13y equals 10. And then I have 5x plus 5y equals 5. All right, so I'm going to subtract these two equations right here. That means my x's are gone. 13y minus 5y gives me 8y, and 10 minus 5 is 5. Divide both sides by 8, and I get 5/8. So 5/8 of a pound is created from our Kona beans. So again, if this helps, we can write Kona on here. Okay. Now, if 5/8 is Kona, that would then make 3/8 of the pound need to be Sumatra. Okay, because we're talking about 1 pound right here, and we've already got 5/8 represented, and then we've got 3/8. Okay, but let's go back. This is talking about a 50-pound bag of coffee on here. So if we take our Y and we need 50, what's 5/8 times 50? Well, that gives us 31.25 pounds. Okay, and again, this is our Kona. Okay, versus if I do 50 times 3/8, then that would give us 18.75 of our Sumatra. Okay. So again, we just got to be careful on there. We want to start with the 1 pound because we know the cost per pound. We know that each pound is a blend of the 2 different kinds. And then we can go ahead, once we find X and Y, project it to a larger bag of coffee.